Good afternoon, everybody. Hello and welcome to the Lunchtime Discovery Series. Glad that you could be here for another edition of this great program brought to you by the North Carolina Office of Environmental Education within the Department of Environmental Quality and us here at the North Carolina Museum of Natural Sciences, bringing you amazing people doing really interesting work, talking about interesting topics just about every Wednesday, right here noon at the museum's YouTube channel. As always, today we've got another great program for you. Today we're going to be talking about a topic actually that I really enjoy learning a lot about. We're going to be diving into climate change, specifically some of the tools that are out there to help people make sense of it. And we've got a very special guest who's going to be walking us through that. I'll remind everybody that the Lunchtime Discovery Series is interactive. So you don't just have to sit there and watch. Well, you're going to sit there and you're going to watch and listen for a little while, but then you get to interact in the program. Make sure that you are in the chat on YouTube or in the comments on Facebook. Let us know about your thoughts and particularly your questions for today's guest speaker. I'll be going to those after the presentation, and we'll start a little bit of a conversation between our guest and all of you, our viewers. Also, remember that if you like this program, you can go back and see past presentations, watch past speakers talk. Just check out the playlist on the museum's YouTube channel under Lunchtime Discovery Series. There's a lot of really great stuff from really interesting people. So a great resource there. Make sure that you're taking advantage of that as well. Let's get those view counts up on our YouTube videos. It helps out the Office of Environmental Education. Wink. Let me introduce today's guest speaker, and let's get into the program. Today, we're going to be hearing from the Climate and Energy Program Coordinator with an organization called Climate Interactive. Everybody put your hands together and welcome Janet Chikofsky. Hey, Janet.
Hi, Chris. Thank you so much for having me here. I am super excited to share with you what we do and one of our tools today. So as Chris mentioned, I am the Climate and Energy Program Coordinator at Climate Interactive. So we are a small not-for-profit think tank, and our mission is to create accessible, scientifically rigorous tools that drive effective and equitable climate action. All of our tools are freely available. The tool that I'm going to show you today, you can go and play with yourself and use it in your classrooms, use it in your conversations. We are a global team. So I'm located here in North Carolina. We also have team members in different areas around the world, in Turkey, Germany, Nepal, as well as here in the US. And let me share my screen. I have a few slides to show you. All right, that's a simulator. Can you see my slides now?
Yes, looks lovely.
Awesome. Okay, so the simulator that you are going to see today is called Enroads, and it was developed by us at Climate Interactive in partnership with the MIT Sloan Sustainability Initiative. So Enroads is freely available. It is a transparent policy simulation model. It allows you to try your own assumptions and get immediate feedback on the results. It's a place where we can experiment. We ground it in the best available science that we have, and we also update it every month to reflect new research, new consensus. The emphasis of the model is really on learning. We have found that research shows that showing people research doesn't work. It doesn't really inspire action. It doesn't really drive change. And what does work is giving people a tool that they can play with, that they can use to experiment, kind of challenge some of their assumptions, improve what we call their mental model, the model between their two ears that helps them make sense of the world. And so that's part of our mission here, is to enable people to learn by giving them this sort of tool. So today, kind of an overview of what we'll be doing. We'll be exploring the Enroads simulator. And along the way, I'm going to make this interactive. I'm going to ask you what you want to test in the simulator, and I'll be asking you for some responses. I'll be using a polling software called Poll Everywhere to do that and to gather responses, and I'll show you how to do that. If for some reason you have problems with the polling software, you can also use the chat. We are going to create together a global path of action to achieve the Paris Agreement goals of mitigating climate change, of keeping climate change below 2 degrees Celsius, 3.6 degrees Fahrenheit, and really aiming for 1.5 degrees Celsius. These are the internationally agreed upon goals of the Paris Agreement. These are what scientists tell us are really needed to stave off kind of the most catastrophic effects of climate change. I will also be showing you how to use En-ROADS and understand some of the educational resources that we have developed along the way. So just to give you an overview of where En-ROADS is used, it's been under development for over 10 years now, but we officially launched it at the beginning of 2020. And we've had over 80,000 people in over 86 countries participate in En-ROADS simulations. It's to kind of give you an idea of its reach and its impact. I have a quote here from John Kerry. We have used En-ROADS in conversations with policymakers here in the US. I think something like 37 senators on both sides of the aisle, Democrat and Republican and independent have used this tool, experienced En-ROADS, as well as business leaders and people in different decision-making capacities. One thing I like about what John Kerry says here is I think it sums up this tool very well. He says En-ROADS is the ultimate conversation starter. And that's really how we view it. It's not a tool to tell us what's going to happen in the future. We're not using it to predict. We're really using it to learn about what is high leverage, what is low leverage, how does the climate and energy system really behave. So like I said, we are aiming for these Paris Agreement goals. And I'm going to switch over to the simulator now. And Chris, just to double check, can you see the simulator on your screen? Perfect. All right, so this is En-ROADS. If you want to know about the acronym, En-ROADS stands for Energy Rapid Overview and Decision Support. There's no quiz, you don't need to remember that, but people ask me all the time. And this is a climate and energy simulator. You can find it online. Just go to enroads.climateinteractive.org. I'll give you the link at the end. And this is a model rooted in a type of modeling called system dynamics. And this allows us to see the relationship between different climate actions, because a lot of times when we think about climate actions, we think about them in sort of a silo. We think about, okay, what might happen if we do just one thing without taking into account how it might impact other systems. So En-ROADS is able to kind of give us a holistic look at what else might be changing in the system when we take an action. In the back end, there are tens of thousands of equations running that restructure the model every time you move a slider. Another interesting, useful thing about the model is we have translated it into, I think, 13 languages at this point. So for example, if you wanted to use En-ROADS in simplified Chinese, you can do that, or traditional Chinese, as well as German, French, Bulgarian, Turkish, etc. And I will give you kind of a quick orientation to this simulator. So it is a global climate and energy policy model. This is not just the US specifically, it's not just North Carolina. It is looking at the entire global system. We have a baseline scenario here. That's what we're looking at right now. It's what we see when we just open up this simulator. And this baseline scenario describes a scenario with no significant climate action beyond what we have in place on the ground today. We see it as a kind of reasonable starting point for experimenting. What would the world look like if we really don't take action? Because energy demand and economic growth and population are continuing to increase over the century, and because of our current energy mix and current trends in energy prices and use, this baseline scenario is showing that emissions, that's this graph on the right, emissions of different greenhouse gases are going to increase by 2100. And that is going to lead to this temperature increase over here on the right of 3.6 degrees Celsius by 2100. This is, if you're more used to Fahrenheit, this is 6.5 degrees Fahrenheit. So this is a lot. This is far beyond the Paris goals of 2 degrees Celsius and 1.5 degrees Celsius. And our goal today is to construct a scenario that will really bring the temperature down to those Paris goals. It can be done. That is kind of one hopeful thing about the simulator, and it can help show us different ways to do it. There is no one right scenario, but we can explore. So let me show you quickly how it works. And to do that, I will show you down here at the bottom are 18 different sliders, and I'll describe each of them in a minute. But I'm going to show you my favorite slider. It's called New Zero Carbon. And these sliders allow us to control different actions that we could take. So this slider, I think, is one of the coolest things ever. And, you know, with my definition of cool, you know, I was a riot in high school, but I think it was the coolest thing ever. And it allows us to say, well, what would happen in the world if we suddenly had hydrogen fusion or another new source of energy that does not emit carbon dioxide, and that was really cheap, was cheaper than coal, which is very cheap, and we were able to scale it worldwide. So I'm going to move this slider. That is going to simulate a huge breakthrough in the year 2022, next year. We're going to say that in 2022, suddenly a lab somewhere at Duke or UNC or Stanford or MIT, someone somewhere, or Tsinghua in China, comes out with a breakthrough, let's say in fusion, or it could be in thorium fission, something like that. So I'm going to increase it to a huge breakthrough. And you can see that the system changed. I will replay that change. You can go up here. There's this handy replay last change button. I will click that. And you can see that things happened in the model. So over here, we have our sources of energy. This is our energy mix, how we power our world. Going from 2000 to 2100, the amount of energy we use each year. And we can see that suddenly this orange wedge appears. This is the new energy source taking off. You can also see the other energy sources here, such as coal, oil, gas and blue, renewables, so wind, solar, geothermal, bioenergy, nuclear, and then the new zero carbon. You can see that this action had an effect. We did reduce emissions a little bit, and the temperature changed. Temperature went down from 3.6 degrees to 3.4 degrees. So it helped, but it might not have helped quite as much as you would expect, as I expected when I first saw this. I thought this would be the holy grail. I thought if someone has a breakthrough in fusion, well, we're most of the way to being saved. Unfortunately, that's not quite how the energy system works. And the model helps us see kind of a few different reasons why, some of the dynamics that are driving this. One is that there's a delay in the system. It takes a while for this new source of energy to scale up. So we have a breakthrough in 2022, but it's not really until really the 2040s that it starts to take off. That's because, you have a breakthrough in a lab, but then you need time to commercialize it. You might need to build a pilot plant and demonstrate that it's safe. You need various permitting. You need to train people on how to operate this new thing. You need to acquire all the materials. It takes a while. So there's a delay in the system, and the model will reflect that. Another thing we can look at is that we just added a brand new source of energy to the mix that is really cheap. And so we lowered the overall cost of energy, and we can see that here. I have these miniature graphs that I can look at. So I'm going to look at the cost of energy. And suddenly energy costs less because we just added something that's really cheap. And what happens when energy is less expensive? Well, if I forgot to turn off my lights when I leave my house and my energy bill is really high, I might circle back, might turn them off. If it's really low, probably won't. Just human nature, where is my time best spent? So we also see that if the cost of energy goes down, energy demand, this is final energy consumption, so how much energy we're using, that will go up a little bit. And this kind of counteracts some of the helpful effect of adding that new energy source, just because we're using more energy. And so that new zero carbon energy, some of that is just going to meet the new demand that we suddenly have rather than displacing those fossil fuels. So I've shown you how this works and some of the dynamics. I am going to switch over. I'm going to undo that so we are back at our starting point, because I want us to create a scenario together. I'm going to switch over to a polling software. So this is called Poll Everywhere. What you can do is you can go to pollev.com/climate-inter935. And you can enter your name if you want. If you don't want to, no worries. And then you can respond to some of the questions I'll be asking so that we can make this interactive. And so my first question for you is, which climate solution would you like to propose at a global scale? So this could be something that you want to see implemented, that you're really excited about. Could be something that you just want to see what the effect might be in this scenario that we're creating. So what you can do is you can just click on the image. So if I wanted to, for example, reduce coal use, I could click on coal now and just put a pin there. And then what I'll do is I will take a look at this and see what kind of is garnering the most interest, and then we can test it out in the simulator. And as you're doing this, I will go through and tell you what each of these are. So our energy supplies are coal, oil, and gas. We can tax these. We can reduce their supply in other ways. We can say no new coal plants, for example. We could subsidize them if we want to. Also bioenergy, so that is things like burning wood for fuel or electricity, ethanol, we could subsidize or tax it. Renewables, we could subsidize or tax. And by subsidize or tax, what I mean is we can do things that will incentivize having more renewables. Nuclear, new zero carbon, I went over. Carbon price, a carbon price is basically putting a price or a tax on fuels according to how much carbon they emit. So this will really affect coal, oil, and natural gas, but not renewables. And then we have ways we can affect energy demand. So transport, buildings, and industry, we can look at energy efficiency and electrification. We can also look at greater or less population or economic growth. And then finally, over here, we have other sources of emissions. So land and industry emissions from chopping down trees, deforestation, or from methane and other greenhouse gases. And then finally, ways in which we can actually remove carbon from the atmosphere. Things like planting trees, afforestation, or technological carbon removal. This is kind of experimental methods like direct air capture, agricultural soil carbon sequestration, things like that. So I'm seeing a bunch of responses. Thank you. I will kind of write down the ones that are having the most interest right now, and we can look at them. So I see coal, I see afforestation, and energy efficiency of buildings and industry. That's one of my favorite. Industry and carbon price, renewables and nuclear. Great. Thank you all for your input. So I'm going to start with coal. And so I'm going to be moving that coal slider. So before I do so, I'm going to show you the scenario. We're back at 3.6. We're going to start building a scenario from here. If I were to really disincentivize coal, if I were to put a tax on it, if companies were going to say, you know, we're not going to use electricity from coal-fired plants, if government regulations were going to say no new coal, what effect do you think this would have on the energy system? And keep in mind, this is a global model. So we're not just talking about the US or North Carolina. Where do you think the temperature would drop to? You already saw that we had a drop from the new zero carbon, but we're back to 3.6 to just build a scenario from here. So I'm gonna go to the next question. I'm gonna activate that. And tell me, what do you think this scenario's 2100 temperature will be after moving the slider? We're starting at 3.6 degrees Celsius. And feel free to make a selection. Totally fine to be absolutely and completely wrong. I know, I don't think you could be more wrong than I was the first time I played with a model for any of these levers. So please go ahead and see if you can improve on my track record. Great, I see we are already getting some responses in. Right now it's in the 3 to 3.3 degrees category. I'm going to wait for a few more responses. Also, if you prefer texting, if you're a millennial like me or just an aspiring texter and prefer it over computer, you can also, for these questions, text climate inter 935 to 22333, and then you can make selections. All right, so we have more responses. It looks like 3 to 3.3 is winning. I'm actually a little bit surprised. I feel like there are pessimists in the house here. When we did this with Stanford grad students, they were like down in the 2.5 to 2.9, 2 to 2.4. Okay, so I'm gonna say, looks like 3 to 3.3 is winning. Thank you, everyone. I'm gonna switch back to the simulator. So I'm gonna add that tax on coal. I'm gonna really heavily tax it. Let's see what happens. So it's really highly taxed. If you wanna know what that looks like, say about $93 per ton of coal equivalent. And we're starting that in 2021. I will replay that change. So 3.6 to 3.4. Let's see, who won? Okay, the 27% of you one who selected the first option. So 3.4 degrees. I'll replay that again. So what's happening here? There's a few different things. So right now, if we decrease coal, we're going to cause renewables to increase, this green wedge here. And you can also see it on just the renewables graph by itself. You can see that it does go up a little bit. So if we decrease one energy source, something needs to fill that gap that gives some room for renewables, and they'll go up. But other energy sources also increase. So natural gas demand will increase as well. And we call this kind of a squeeze the balloon dynamic. So if you have a balloon in your hand and you squeeze one section of it, another part kind of puffs up. And we see this with taxing fossil fuels. If we squeeze one, another one will kind of increase to compensate, unless we have other actions that help us address that, unless we maybe encourage renewables more, something like that. So we can also look at a few other things here. I'm going to flip back to the polling software and ask you another question. And that is, what are some of the equity considerations that might concern you with this policy? If we are taxing coal, what are some things that we might want to think about that might be kind of negative repercussions? Or are there equity-related co-benefits that would arise from taxing coal or decreasing coal use? So you can write these in and they'll appear on the screen here. And that's something that we really try to think about a lot. At Climate Interactive, our co-director, co-founder, Dr. Elizabeth Sawin, has pioneered this idea called multi-solving, which is, in short, it is solving more than one problem with one solution. And it's also this idea of, we're not all in silos by ourselves. If you're working on something, there are probably other groups who are working on things that kind of interact with what you're working on. So while you might not be working on, if you are working on climate change, you also want to partner with other groups that are working on kind of related societal needs, and that would be impacted by those. So great, I'm getting some responses here. So equity considerations related to coal, the loss in jobs would need to be balanced with job training in the growing market for renewables, absolutely. Energy prices could rise, yes. Mining job losses, electricity prices. On the positive side, fewer mountaintop removals, negative for dynamite prices. For dynamite suppliers, better air quality, absolutely. Fewer coal ash dumps, yes, that is something that I know is kind of top of mind for many of us in North Carolina. Regions that don't have ready or cheap access to other sources of coal will suffer, or other sources of energy, I can read today, will suffer with a tax on coal, healthier people, cleaner air, reduced mortality, excellent. Thank you so much for your responses. So I'm going to switch back to the simulator. I know some of these are still scrolling in. Thank you for the input. And we can examine, so we can examine one of them in the model, and that's air pollution. So if you click on the top of any graph, you see all the graphs. We have a lot of graphs. If you go down to impacts, we can look at different impacts of our actions. And I can look at air pollution from energy. And we can see that even with this one action, we've really reduced air pollution from energy in the form of PM 2.5 emissions. So PM 2.5 is a really insidious form of air pollution. It's particulate matter of 2.5 microns or less in diameter, gets really deep into your lungs, is associated with really poor health outcomes, a lot of mortality, a lot of deaths, and coal produces a lot of PM 2.5. So when we reduce coal, we have this co-benefit of reduced PM 2.5 emissions. That is really, really helpful to know. All right, so we have looked at coal. I'm going to go back to my main graphs here, if I can. No, that is not my other main graph. All right, back to the main graphs. So I'm going to build on this. We have looked at coal. Let's look at afforestation. So that's another solution that I saw interest in. So this is planting trees, or kind of removing carbon from the atmosphere through like restoring wetlands, things like that. Plants that pull carbon dioxide out of the atmosphere, lock it into their plant mass. Hopefully it stays there for a while. So if we were to plant a lot of trees, a ton of trees on a lot of land, and I'll show you how much land, but if we were to just really go very heavily into afforestation, back to our handy polling, I'm going to go back a couple. Nope, not to that one. Okay, and I'm going to clear the responses and ask you, what do you think this scenario's temperature will be after moving this slider? So again, you can go to pollev.com/climateinter935, and we're at 3.4. So we plant a lot of trees. This is a climate solution that kind of has got a lot of press lately. There's like the Trillion Trees Initiative. There is discussion at Glasgow at the UN conference recently. All right, so we're getting a range of responses. I'm seeing 3.4, I'm seeing 3 to 3.3, I'm seeing 2 to 2.4, I'm seeing under 2. Okay, we're getting more optimistic as the hour goes on, or you're just getting tired of the higher numbers. All right. Okay, so it looks like 3 to 3.3 is winning. Okay, so much for optimism, but there is some 2 to 2.4 and under 2. All right, let me flip back to the simulator. And I am going to plant a lot of trees. So to show you how many trees I'm planting, I'm going to look at under removals and land use, sources of net CO2 removals. Okay, so this graph is just going to show us how much CO2 we are removing when we plant trees. Right now, we haven't added an action that is planting more trees than currently exist, but I'm going to just scale it up as much as I can. And hey, we planted some trees. Congratulations, everyone. That's as much of a green thumb as I can ever get. So I'll replay that change. And you can see that we have grown a lot of trees. It's taken a while. It takes until we start planting, let's see. So we start planting in 2021. I guess that's what we're doing on the last few weeks of December. I'm going to say the assumptions here is that it takes about 10 years to secure that land for afforestation. It takes about 10 years to really negotiate with landowners. Hey, we want to plant trees in your backyard, on your cropland, wherever. And it takes a while to plant the trees, and the trees take a while to grow. When you plant trees, you don't normally plant a giant oak tree. You often plant little teeny sapling. That isn't going to take out a lot of carbon immediately. It takes a number of years. In the model, we have, besides kind of these advanced settings that you can find by clicking on these 3 dots next to a slider, we also have assumptions that are even more in depth. So you can go up here to simulation and go down to assumptions. And these are even more kind of in-depth assumptions. If you really want to play with the model and you disagree with some of the assumptions that we have made, okay, go have fun playing around with it. So right now, the default assumption is 80 years it takes to grow to really kind of remove a lot of carbon. The maximum available land is 700 million hectares. You can adjust that if you want trees to grow faster. If you think, okay, well, we're going to use species of trees that grow a little faster, you can adjust it to 70 years or even less. So you can see it takes a long time to ramp up. And then by like the 2080s, it's taking out about 7 gigatons. And we can see we dropped to 3.3. So, oh yeah, so because I changed the assumption, I can't go back. So it was at 3.4, we're down to 3.3. So it is not quite solving the climate crisis. It is helping, especially if these afforestation policies are kind of put into place with thinking about equity, thinking about who owns this land. Are there ways to support kind of indigenous rights in this? Maybe kind of monoculture of one species of tree is not the best for increasing or preserving biodiversity. One other factor at play here is that, yeah, we're pulling a fair amount of carbon dioxide out of the atmosphere. And I'll show you quickly how much land we're using for that. We're using about twice the area of India for planting those trees. And let's compare that to the scale of emissions. So this is a handy graph that shows the red line is how much carbon dioxide we are emitting every year. And the blue line is how much we're removing. And the best way to think about this is to think about a bathtub. And I have a handy slide. Here's my handy slide. Okay, so bathtub dynamics. If we think of CO2 in the atmosphere as water in a bathtub, and we have emissions, that's the water coming in, and then we have a drain, which is removals. And removals can include things like afforestation or technological carbon removal. If emissions, if the water into the drain is going in faster than it's removed, the level of water in the bathtub is going to rise. And so while we are increasing the removals, if the emissions are still greater, CO2 concentration is still rising, and as a result, temperature is still going to rise. And one analogy we often use is that before you go grab a mop and bucket, it's helpful to turn down the tap. I actually had an experience with this when my dishwasher started malfunctioning and overflowing. It took me about 15 minutes of frantically calling my landlord and bailing water as it continued to rush in to realize that under the sink, there is a handy tap and you can turn it and it turns off the water supply. I must have missed that day in high school when we were supposed to learn about under the sink plumbing or just common sense. But I can tell you that just bailing it and trying to take out removals if emissions are coming in faster doesn't really work. All right, so going back to En-ROADS. So we have increased removals. You can see, if I go back, then we have increased removals. We've increased removals, but not enough to really alter emissions. And we still have, if I look at greenhouse gas emissions, you can see that this is the same kind of greenhouse gas emissions graph as before, but broken out by different gases. And we can see down here, land use CO2 in green. It's positive until the 2040s, 2050s, because this is emissions from deforestation. And then we added so many trees that it became negative. It's pulling CO2 out of the atmosphere. But that is really small compared to all this fossil fuel CO2, all this energy CO2, as well as the other gases. So I took a long time to cover afforestation. We're going to go a little bit quicker so we can build more of a scenario. I also saw energy efficiency of buildings and industry. So I really like this lever. I'm going to increase this. Currently, energy efficiency of buildings and industry is increasing at about 1.2% per year. We're getting better at using energy and more work for less energy, more bang for your buck. So this could include things like insulating the home or making industrial processes more efficient. It's going to really increase that. And that has a pretty dramatic effect. This is my favorite lever. I will replay that. You can see that all the sources of energy really diminish because suddenly you're not needing as much energy to do what you want to do. And you can see that we are down to 3 degrees. So thank you for that proposal. And then another one I saw was a carbon price. So a carbon price is basically taxing producers according to how much carbon they emit. So coal will be taxed more than oil and then natural gas because coal emits the most carbon dioxide per unit energy. So before I institute a carbon price, I want to ask you about equity. So I'm going to clear responses and activate. So if we are increasing a carbon price, what are some of the equity considerations that concern you with this policy? Oh, that's weird. I think it's taking the old. Okay. For some reason, it is rehashing the old ones. I've never had that happen before. All right, I'm going to activate it again. Let's see. What are some of the equity considerations that concern you with this policy? So if we start making coal, oil, and gas more expensive for producers, depending on how much carbon dioxide they emit. So feel free to write in some of your ideas there. Turning our environmental future over to stock market forces is a bit scary. I agree. There are positives to market driven and there are also negatives. Keep in mind, so this carbon price we're going to implement is a global carbon price, and there are different ways we can implement it. It could be a cap and trade market, kind of like the RGGI, the Regional Greenhouse Gas Initiative that a bunch of northeastern states have. Financial impacts on low-income households, co-benefits include improved air quality, consumer prices will increase, rise of renewable energy, rise in energy prices. Yeah, thank you. So I know I'm going pretty quickly right now. I talk a lot apparently, so I am running out of my own time allotment. So I'm going to switch back to the simulator, but thank you for this is for these equity considerations. So I'm going to add a pretty high carbon price. By pretty high, I'm going to do $180 per ton of CO2. This is pretty high. Right now, I think the average around the world is about $8 a ton. And that had a big and dramatic impact. I'll replay that change. Again, I just keep adjusting that oddly. So we're at 2.5. We're finally crossed the 2-degree mark, or 3-degree mark, math. And you can see that we have really affected all the sources of fossil fuels. We haven't affected oil in red here quite as much as we might expect, because oil is really needed to power our current transportation system right now. If we wanted to kind of accelerate the effect of this carbon price, we could have electrification of transport and even buildings and industry. So it'd be things like companies having corporate commitments to more to buying only electric vehicles or selling only electric vehicles, having more charging stations, etc. I'm going to really ramp that up. And I'm going to say we're going to electrify as many vehicles as possible. So now we're at 2.3. And you can see that it takes a while to ramp up because, we can't really retrofit vehicles, and it takes a while for the whole vehicle fleet to turn over. People are still buying used cars that are run on internal combustion engines. So that's a dynamic we need to think about, is that many of these will have a delay. And so the sooner we act, the sooner we can stop emitting carbon dioxide and other greenhouse gases. So we are at 2.3. I think I will add in a couple here to get us to below 2 degrees. One area that we haven't really touched is the top of this graph here. So these are our other greenhouse gases. F gases, these are fluorinated gases, human-created gases that are used in like refrigeration and air conditioning. Methane, which comes from cows burping and rice paddies and anywhere where you have a lot of decomposition, landfills. And then nitrous oxide, so this is from industrial fertilizers, among other things. So I'm going to try to reduce that a fair bit. And hey, we're below 1.9. Congratulations. There was a great joint effort there. And you can see we're reducing them almost as much as we can. This can be through eating a more of the world eating a more plant-based diet, figuring out how to use industrial fertilizers in a way that kind of isn't overuse, and so kind of being careful about how we're doing that, capturing the methane from landfills or trying to produce less waste, etc. So I'm going to stop there in terms of looking at this scenario, and then I'll talk a little bit about how you can use En-ROADS. I will copy this scenario link and put it in my chat. So Chris, if you can send it over, you all can check out the scenario, play with it yourself. You'll notice that when I share a scenario, I went over here to the share your scenario button. That keeps all my settings and all my graphs. It's a great way to share it. All right, so I'm going to go back to my PowerPoint. I think I need to do a new share because I logged out of the PowerPoint. Okay, this is my not knowing how to use Zoom. I'm going to start my slideshow again. Start a new share. Okay. Can you all see my PowerPoint? Awesome. So how do you use En-ROADS? We have developed a training program to train people in how to use this model. You can go play with it yourself. We have handy resources to do that. You can also, if you want to go more in depth and learn more about the dynamics, how to run events, kind of advanced facilitation tips, go here, learn.climateinteractive.org. And we have a whole course that will, here I can actually show you. So we have a whole course. Here's a great video talking about people who have done the training, what you'll learn, and then all these modules about that with handy videos and quizzes that I developed to hopefully make it fun. If they're not fun, you can tell me, it's okay. And the great thing is that this is now eligible for Criteria 1 credit for the North Carolina Environmental Education Certification Program. This, if you're not familiar with it, this is an amazing program run by Lisa Tolley and Marty Wiggins, and they and one of the committees in charge of it have accepted our training program as credit. toward the certification. So I really encourage you to check it out. If you have questions about the training, feel free to reach out to me. If you go through the training, you can become an Enroads Climate Ambassador. These are trained facilitators. They're featured on our webpage, and I can tell you more about that later. And then we have a few different ways that we have developed to kind of experience Enroads. The workshop we did today, and then Climate Action Simulation is an interactive role-playing game. And the Enroads guided assignment we have developed especially for teachers. The Climate Action Simulation is really fun and interactive. People are in different groups and they negotiate. Some stakeholder groups. I know I'm going really fast. So I left only very few minutes for questions. Feel free to reach out to me if you have more questions. You can email me here, or you can just go to the support page on our website, support.climateinteractive.org. These resources are for you. We love feedback. We love knowing how people use En-ROADS. If you do use it, please register that use on our website so we can understand how it's being used and get feedback. All right, Chris, over to you for questions.
Janet, thank you very much.
Sure thing.
Everybody, you can, great big round of applause for Janet for taking us through the climate simulator. And what a great story to sort of just hit us with these big things like, oh yeah, well, let's take coal all the way to 0. You get 1/10 of a degree. Let's plant
not quite all the way to
5 billion
0, but heavily taxed. Yeah.
Yeah, let's plant 1 billion trees. You get 1/10 of a degree. Because right, that's how these solutions work. Is it's going to take a lot more than just any one particular solution.
Exactly.
But
together,
what a great story to put together. The folks in the chat were just getting like really antsy, like, come on, do more, get us to below Paris. If there
I
are
did
some
take a
questions
while
for you.
explaining, so it was abbreviated getting below there.
So I did share the link for the scenario. I was like, we saved the world. So that's there in the chat, everybody. But okay, questions from the audience. There's a few here for you. Katie's curious about the scale that's used for each of the sliders, because Katie noticed that status quo is in a different position on the slider, so that you could go one way or the other for some of them, and others status quo was like all the way to the left.
Yeah. Can I share my screen again? Will you be able to see that?
Yeah, sure.
Cool. Yes. So Katie, you are spot on. So we designed the slider ranges to be kind of ranges that we found reasonable. And so for some of them, for like transport electrification, it goes from like 0 to 100%. But for others, for example, population, we take the kind of high and low ends of the UN's medium population scenario as ends of our slider. So it's not, if I move population all the way down here, I'm just saying lower growth. I'm not saying there's no people. I'm saying there's going to be 9.1 billion people. The status quo, it's 10.9 in 2100. For the energy supply sliders, these are all kind of a similar percentage increase for each. And you can, let me show you. Over here, we have this I button, and you can open our user guide and look at examples and dynamics, but then look at what the slider settings mean. And so for each of the energy supply sliders, it's the same kind of percentage increase or decrease for each of their kind of like categories, like very highly taxed, etc. But for other sliders, it is a bit of kind of what we think might be reasonable, and then you can change a lot of those assumptions yourself.
Excellent, excellent. Next one's for you. Herman brought this up a couple of times. I think Herman in the chat is trying to get like carbon credits for the lumber used to build his house and his furniture.
Mhm.
Wanted to know if afforestation includes CO2 sequestration in wood-based products.
Interesting.
Like you
Yes, I
plant the trees
suppose.
and then you cut them and turn them into things like Herman's bamboo bed set.
Oh, nice. Um, yes, if you're not releasing that carbon dioxide, if it is kind of sequestered in some sort of way, then I'd say then yeah, it would qualify. Trying to think if it would be under afforestation or technological carbon removal, but probably afforestation.
There you go. Okay. You mentioned at the very top that this was a global model,
Mhm.
but one of our viewers was curious about regional increases or regional differences.
Yeah, yeah. So it is a global model. Kind of the way that we have created it is fairly top down, and it's not kind of disaggregated by region. Economic growth, for example, we do have kind of regional economic growth in the model. If you want to, it's really looking at kind of what is high and low leverage globally. We do have another model called C-Roads. Let me pull it up. C-Roads. So C-Roads is kind of, it was the precursor to Enroads. And we were using this a lot around like the Paris Climate Agreement. And it looks at kind of 6 regions and how they might reduce their emissions. It's built a bit differently from En-ROADS. It focuses more on the climate and country pledges than it does on solutions. But if you're curious about different kind of regional emissions and rates and stuff, you can check out C-Roads. It's croads.climateinteractive.org. C-Roads stands for Climate Rapid Overview and Decision Support.
Excellent. Another question that popped up, which I don't know, maybe you know the answer to this one. I don't think I know the answer to this one, and I feel like I should. Do conifers sequester more or less carbon than non-conifers? I don't know if that
Ooh,
was in the model.
that's a great question. So I
It's a
know
good question, Glenn.
yeah, we model a global average. We have a couple of very in-depth blog posts about how we model afforestation.
That's
see if I
great.
can
There
pull
were
them up.
several questions that did come in where people wanted to know about the math behind the afforestation in particular.
Yeah, totally. So let me put this in the chat. I think we also have another blog post that's even later than this. Yeah, this is like a follow-up one. Yeah, because a couple of years ago, there was a big scientific article, Bastin et al. This is a note on its erratum. And we've done a lot of work looking at kind of afforestation and as well as bioenergy. So I don't know about conifers. That's a great question. And I know who to interrogate among our modeling team about that, but I can't do it right now. But feel free to follow up by emailing me.
I'm just going to throw out there as an environmental educator, plant natives. Just we'll start there, Glenn. All right.
Yeah.
Let's see, just a couple of more. We're over time, so I'll hit these quick. Should there be an ocean health slider or soil health in regards to CO2 buffering?
Oh, interesting. So we take into account absorption by soil and the ocean. And that's kind of way back end of the model. I know we have modeled the ocean by, I don't know, like several layers, mixed layers and everything. In the model, you can look at impacts. I didn't get to this. You can even look at flood risk from sea level rise. We have a map, but we also have ocean acidification. So you can look at what effect your scenario would have on ocean acidification, because when CO2 is absorbed by the ocean, it becomes carbonic acid, which is acidic.
I'm really impressed. This is a really robust tool.
Thanks. I have really cool colleagues who devote a lot of energy to it.
Exciting stuff. Well, Janet, thank you so much again for being on the program today.
Sure thing. I had a lot of fun. And if anyone has follow-up, feel free to email me or reach out to us. Yeah, this tool is for you. And thank you, Chris, for hosting.
Oh, yeah, of course. The Office of Environmental Education also dropped a few links in the chat on YouTube, everybody. If you want to learn more about the environmental education certification and this Criteria 1 credit that you can get with the En-ROADS Simulator workshop. So make sure you take advantage of that. If you're interested, you can reach out to us at the museum, the folks at the EE office, or get in touch with Janet to learn more, of course. For contact information, I think they can probably find you. What was the climateinteractive.org? Is that right?
Yeah. And then okay, easiest way to get in touch with us is support.climateinteractive.org. But yeah, just check out our website.
All right. There you go, everybody. I do believe, I might be wrong, but I do believe this is the last Lunchtime Discovery Series presentation for 2021. That's right, everybody. Next time that I see you, we will be in 2022. So enjoy your holidays. Enjoy your days off, maybe. I hope that you get some breaks in there. If you're traveling, stay safe. If you're not traveling, if you're not celebrating, you know what? I hope you have a great time too, because I want to see you back here in 2022 for another edition of the Lunchtime Discovery Series. We'll be back here the first Wednesday on the 5th, so don't miss it. I'll see you again real soon, everybody. Bye.